Hey guys, and we are back with a repair video. Today we are working with a retro motherboard. Now this is an OEM motherboard. They are less desirable, so if you want to bargain, look out for these. It's for the AMD Socket 939 with PCI Express and a chipset from Nvidia. Very retro friendly. We have ID and floppy, but also SATA and all the usual ports like PS2, serial, parallel, Ethernet, USB audio, it's all there. But this one also has VGA out with onboard graphics. The board actually works. Here I am in the BIOS tweaking a few settings, but later I found out there's just something a little bit off with this one. Let's try to identify this board. There is a model number here, L-NC51Q. And then there is another one at the front edge of the board, K8N5GM. Typing this into Google, I'm getting some information through the retro web Lenovo L-NC51Q. The picture definitely matches what we have at hand. And down here it's also known as a board from MSI as well as one from QDI, with the same model number that we have written on the motherboard. I quickly installed Windows XP, which worked without any dramas. It can boot from a USB optical drive, and then I'm running 3D Mark, looping it, and yeah, perfect stability. I didn't have any issues until I started looking at the board with a thermal camera. Recently, I reviewed the ThermalMaster P3 thermal camera on my main channel, so this was a good opportunity to inspect the board and see if anything is off. And here we have some footage. This is the area around the CPU socket. So these are MOSFETs, basically a buck converter, stepping down from 12 volt to the CPU voltage. And the capacitors are all looking fine. They're all from Panasonic, FJ, FR series, good quality stuff. And the temperatures I'm seeing here are nothing really that concerns me. But then I noticed a hotspot right here. It's at the back of the keyboard where the ATX connector is, near the RAM sockets. And this area is responsible for the voltage supply to the RAM slots. And you can see one of the parts is sitting at 110 degrees, so very concerning. I'm just adjusting the camera to get a better angle. And the capacitors also, this one here 75 degrees, the other one around 70. And I've been speaking to ChatGPT. It believes the capacitors, the ESR has been going up and therefore causing issues with the voltage regulation circuit here, and that I should replace them and then maybe everything will be fine. So we're gonna do some desoldering. Recently I bought this desoldering station. It is from Pros Kit, the SS331. I'm also gonna use a few other tools. My main soldering station is from FNERSY. It is the DWS200. And I'm also using a hot air gun. This one is also from FNERSY, the SAG55. Because I'm still a little inexperienced and not so confident with some of these tools, well, I was lucky. I found another listing for the same motherboard, but listed as faulty, not working. So I bought it. This will be our practice board where I'm gonna practice all the desoldering and modifications beforehand to get the confidence, to get the experience, and then hopefully I will not destroy the board because I really want to see it working and I want to do a video about it and use it for some retro gaming. I'm switching on the power supply and you can see at the bottom right corner the red LED lights up, and then I'm turning on the power supply. Now the power supply fan is spinning, but the board is showing no sign of life. The CPU fan is not working. So really, yeah, the listing unfortunately is correct. This board doesn't work. Let's put it under the microscope to have a look what the device is that is heating up so much. It's this one here, a 1084. This is a linear voltage regulator, an adjustable one. there are two resistors nearby. You can see them on the left side, and they configure the device for the voltage. It's outputting 3.3 volts, which is quite standard for retro computers. Let's have a look at the capacitors. We've got 5 of these 220 microfarads with 16 volts. LH Nova, it's a brand I couldn't find any information on. So there are 5 of these caps. They have to go, and there's also one larger one. This one right here, 1000 microfarads, 6.3 volts. Let's have a look at the replacements I bought from LCSC, Panasonic, from the FR series. I've been told they are very good general purpose capacitors. 1000 microfarads, 6.3 volts, and you're looking at $1 for 5, so not too bad. And here we've got the one with 220 microfarads. I made sure I matched up all the dimensions and also the pin spacing, so shouldn't be any surprises. This one here, let's have a look at the price. Well, you get 5 pieces for 55 cents, so that's fairly okay. So what I'm doing here is I'm applying some fresh solder. I gave this a go recently when doing some desoldering and had huge success. I've also gotten a few comments on that strategy. So it takes a while to heat up that component. The issue here is, although the soldering station has 200 watts of power, the thermal mass, the tip is really quite small. You want to have the largest tip that actually sort of fits to transfer enough heat, and you can see it's definitely struggling. I believe the pin on the right was the ground pin, so it was a little bit harder to melt. This one should be a little bit easier, but yeah, you can see now that the solder is melting. That pin is a lot easier. This one is not connected to ground. So by applying fresh solder, we are basically lowering the melting temperature and then making the desoldering process easier. Off to the next pin. This one again seems to be a ground pin. You can really see how much longer it takes compared to the other one. And now let's see the difference with the pin that's not connected to ground. We should see the solder made pretty much right away. I'm adding a little bit of solder onto the tip just to help with the thermal transfer. It's just a little trick I've picked up and seems to work quite well. Here is the next capacitor, getting the treatment of applying fresh solder. Again, this might be a ground pin. You can see how it's struggling. In terms of temperature, I believe I've set it to 375. Going forward, I should write these settings down because it's hard to forget. At the moment, I'm trying all sorts of settings on all my equipment, so it's a little bit hard to remember what the exact settings I'm using, but I don't think it's 350. I'm pretty sure I increased it a little bit because this board uses lead-free solder, has huge ground planes, so you want to have a little bit more heat. But all in all, this is working quite well. We haven't preheated the board. We're not using a PCB preheater. We're not using a hot air gun, just a standard solder iron, and that seems to be working just fine. There we go. One more. Let's check out this one, and then we might jump forward to the desoldering process because at this point, yeah, we get the idea. You apply fresh solder to make desoldering easier. The next step is applying some flux. I got comments, you can't have enough flux, even for the desoldering. So let's give this a shot. Personally, I don't like to add additional flux unless it's really a situation where we have to. I like to rely on the flux that's inside the solder wire, but I have a good PCB cleaner, so it shouldn't matter too much, and let's see if it makes a difference. And now let's try the desoldering. So I've got my desoldering gun ready to go. In terms of temperature, I set it quite high. I believe I set it to 400 C, so keep that in mind. And yeah, the first leg seems to have been desoldered quite fine. we should get a good view after I move the gun out of the way. Yeah, the left one much better. So you can see the difference between the one that's sitting on ground and the one that doesn't. So here I'm doing it again. And I'm not using hot air. I'm not using a PCB preheater. So here I'm just relying on the desoldering gun. And I do seem to struggle a little bit. And well, as we watch the video, you will see how the story unfolds. So let's see if I can get that capacitor out. It's looking pretty good, but not good enough. So I couldn't get it out. So I'm applying fresh solder again. You might have to repeat that process a few times, adding solder, trying the desoldering to get success. Here we go. Let's see if it makes a difference. And yeah, it dropped straight through, so that one came out nicely. Let's move on to the next one. I'm working on the left joint. That one is easier. It's the one that's not connected to ground, so I think this one will come out just nicely. But you can see I'm spending a lot of time on that one and wiggling it a lot, so we will later see that is probably not the best strategy. Well, it sucked it clean, so that's looking good. The other one didn't come out, the one that's on ground. So again, need to apply some fresh solder to make things easier. A comment about the audio. I don't have audio in this part, which is a little bit of a shame. And it's to do with the digital microscope and not having a microphone. Because if it did, then you can just use a portable audio recorder and then sync everything in the video editor. So I've got my eyes out on a different microscope, which has a built-in microphone. Now look at that pin. That worries me a little bit. You know, the capacitor comes out, but the pin, it's almost like the pad disappeared. So curious about your feedback. I might have to adjust my method of desoldering these capacitors, because if the pads end up melting away, well, that's not a good outcome. We are off to the next one, but let me just circle back to the microphone. Yeah, I've got my eyes out on another digital microscope, but what I really like about the one I currently have is it's got this nice arm that you can just swivel away. You can push the entire microscope out of the way, and you can also work with huge PCBs, whereas most of the basic digital microscopes have a little stand. So I still have to do some research. It seems that the mounting mechanism is all the same. I'm pretty sure they all come out of the same factory. I've seen the exact same microscope with different logos on AliExpress, so I'm pretty sure they're all coming from the same factory in China. So I'm hoping that the mounting mechanism is the same, and you can just, take one digital microscope and put it on the arm that you already have. So here we're making slow progress with the desoldering. We can see that the ground pins, they seem to have square pads. So maybe that's the way to distinguish them. The square ones are the ones on ground. The round ones are not. And yeah, the round ones definitely are coming out much easier, much cleaner. You can see the square ones look quite messy. I don't think my technique is right. I'm considering changing my approach in a little bit, so we'll switch to that part very soon. And here we can see the problem. I'm really spending a lot of time wiggling around with no progress, and look at that mess. It's like the whole pad or the whole area just disintegrated. And now I'm using a tool to try to rip out that capacitor, but it still doesn't want to come out. So even with flux, even with applying fresh solder and having a quite decent, desoldering station, it just doesn't want to come out. So I'm applying some more fresh solder, and then I'm going to attack it with the heat gun. I had good success in the past with that method. And here we go with the hot air gun, applying some heat. The hot air gun is set to 350, so it's doing a really good job of heating up the surrounding area. And there you go. You could see the difference. It sucked out that hole perfectly clean. Yeah, so that capacitor should come out now. One more attempt. Let's see how we go. Wiggling the tool, and there you go, it dropped down. The board is quite a mess now. We can see there's a lot of flux or other leftovers. So I'm using the mechanic PCB cleaner and these little sponges that you can buy in a pack of 100 and a little set of tweezers, and yeah, doing a good job cleaning up everything. And here we can see the disaster. I think these pads are gone. Well, that does not look good. Let me know what happened here. If the temperature was too high. Well, you can see really, oh, there's a damage around one of the traces even. So really not happy with that work. Over here we can see a lot of damage. So maybe the temperature is too high or just using the tool way too rough. My technique definitely needs some improving. So because that wasn't really what I wanted to happen, and this is still on the practice board, so it's all good, I tried a different technique, not applying fresh solder and going straight with the hot air gun. And I'm using a different process now. I'm basically for 10 circles, I'm circling around the pin to heat up the surrounding area, so not focusing too much on just the pin, but the surrounding area. And we can see it seems to be working much better now. So let's go over the desoldering once again. You can see that's looking pretty good. Let's move on to the next one. So I literally just counted, 1, 2, 3, 4, doing 10 circles around just to have a consistent approach. The hot air gun was set to 350, the desoldering tool to 400, and that seems to be working quite well. So no fresh solder now, no PCB preheater, no flux. You can see that one came out beautifully. The capacitor just dropped down. So I think this is a strategy that I will use going forward. Let's do another one. I'm actually not quite sure if this is a capacitor I'm going after or an inductor. I think it's an inductor. It's a larger component. Let's see how this one works. And also, beautiful. You can see those joints came out wonderfully. And also I'm being more gentle with wiggling the desoldering tool around. You have to you still want to push it down a little bit because you want to create a vacuum seal, but not like before where I was just really manhandling that tool. Oh, look at that. That's beautiful. So I think I'm ready to move on to the real board. Here we go. This is where it counts now. So this is the board I want to see working. I'm using the same strategy. The first cap, yeah, that looks fine. 10 circles around to heat the surrounding area. And guys, look, this is me sharing what works, what doesn't work. I'm still a beginner. This is my electronics journey. So if you see something and you want to scream at the monitor or your phone, yeah, leave a comment, share your opinions. That one came out nice. It literally just dropped down. Here's the capacitor. Look at that. So they are coming out much nicer now. These two, one out, second out, wonderful. One hole was a little bit stubborn. You kind of can put in a new cap, but I really wanted that hole to be cleaned out, so just going over it again, all good. And now it's time to put in the replacement capacitors. The white marking is negative, and you want to line that up with the negative marking on the capacitors. And now time to solder in those capacitors, applying heat from one side, then adding a little bit of solder onto the tip to help with the thermal transfer. And then you've got to wait long enough. It's a little bit of a game of being patient, touching the joint with the wire and seeing if it's hot enough to melt, and then just feeding the solder. So nothing too difficult. So here you just have to be patient because, again, this is a multi-layer board with huge ground planes. So it doesn't happen as easily as with a little kit. Here we go. This is a round pin, so not connected to ground. You can see a solder flowing quite easily. Let's move on to the next one. That's a ground pin. So here you have to really make sure you're touching both the pin of the component and also the pad, and then feeding in the solder. There you go. That's looking pretty nicely. And next come the tweezers to cut the wires. Well, I didn't quite get the camera aligned properly for this part. And then again, removing the excess flux from the board with the PCB cleaner from Mechanic. I'm curious what sort of cleaning solution or cleaning process you guys are using. But there is more. After doing the capacitors, I thought, hey, why not also replace the voltage regulator just in case that component is faulty. You've already got it on the bench. So I went back to the non-working board to do some practice. And of course, I watched some YouTube videos. I'm also reading a lot on the Reddit soldering group to get information. The easiest way to desolder this one is to cut the legs first, and then the next part is heating up this area here and applying fresh solder. This takes a while because it's basically the PCB is a big heatsink for this component. So I'm adding fresh solder. You can see it's moving now, and then you just flick it away with the soldering iron. Here I'm using some solder wick to suck up some of the excess solder. It's looking quite messy, but a lot of that is just flux that's spitting out of the solder braid. So nothing to be concerned about, and we'll give it a good clean. So that was successful. Let's move on to the motherboard where it counts. I'm cutting those two legs. The one on the right is the input, and the one on the left is the one that determines the voltage. And the large part that's soldered onto the PCB, that is the output. Heating up this part here, applying some fresh solder which has flux inside, and out it comes. Again, we're using some solder wick to suck up some of that leftover solder, and some more on this side. I admit, working with solder wick, it's not my favorite thing to do. The solder wick I'm using is also again from Mechanic. I might put some screenshots of the products on the screen when I mention them, just so you know what it looks like if you want to buy some on AliExpress. But yeah, again, the mess around the area here, it's just flux. So let's clean it up. Here we go with the PCB cleaner, and you can see it's making a big difference. Already looking much nicer. There you go, looking much nicer. We are ready to solder on the replacement part. And again, I want to practice first on the donor board. I think that's a really good strategy, but it's also a luxury. I don't think most of the time you have to have another board lying around to do some practice. But with used parts, well, if you find a non-working part advertised, and they go for a very low price, so why not? It's the experience that's counting. So here I'm aligning the part with some tweezers, and then I'm using a little hack. I picked up some blue tack to lock the component in place. You don't have to do this. You can solder on one leg first to tack the component down, but I find this gives me just a little bit more confidence. And here we go. I'm using the solder iron to heat up that pin here. Again, we need to wait for both the pad and the leg to heat up, and now we can see it's hot enough. We can feed in the wire, the solder wire, and everything is flowing nicely, and we've got a good looking joint. Here we go on the other side. Takes a bit of time for the heat to heat up both the pad and the leg, so you just have to be patient here and sticking the wire onto the area, and eventually it will flow. And this step will take longer because the PCB acts as a heatsink. So you are really fighting against that PCB heatsink here. So you just have to be patient. It's all about thermal mass. Try to make the tip as large as possible. It's not really working that well. Maybe I'm being too impatient. The solder is sort of flowing. We can see it's bubbling here on the PCB area. I think this is a good solder joint, but maybe not the best. Not the best work, that's for sure, but it will definitely stick and work. So let's move on to the board where it counts. Here's the replacement component, aligning it with the tweezers. Again, we're using blue tack to hold it in place, and here we are heating up the first leg. So here I was just a little bit unsure if I'm putting the solder wire onto the tip, so I adjusted the tip a little bit. That's looking good. Let's move on to the next one. Here it's a little bit crowded, so you have to be careful. And using a microscope really helps. It just makes that job much easier. I'm older, my vision is not that great anymore. With close-up, I need reading glasses, so using a digital microscope really makes that job easier. And here we go. I'm fighting the PCB. Now I'm twisting the solder tip in a different direction, trying to give it more thermal mass, and I think it's working because compared to before, the solder is flowing much nicer. So I think we've got a good joint here that should be strong and last. And let's clean it up with some PCB cleaner and make it look good. And here's the magic moment. Hopefully the board still works and I haven't destroyed another vintage computer part. So here I've got a little button for the power connector, and then I'm attaching a little speaker to hear the post beep. And now comes the magic moment. I'm gonna turn it on. Hopefully we see some action. There you go, the CPU fan is working. I can hear post beep, so yes, the board is working. I'm inserting another stick of RAM because I want to stress that voltage regulator. Also, this motherboard is capable of dual channel memory, so we want better performance, especially for the onboard graphics. So I'm adding a second stick. It's posting. We can see a BIOS screen, so that's wonderful. Unfortunately, the temperature is still very high. We can see it here. The voltage regulator 104C, and then also at the top here, that other component, same temperature, it's a diode. Now, it's right next to that voltage regulator, so maybe the heat travels through the PCB into the diode package. It's hard to say. I'm thinking of replacing the diode, but maybe it's not worth it because, well, I had a conversation on the Discord about repairing parts, and, well, the people that know more than me, they said, look, these components are rated up to 125C, 150C, and maybe it's just a poor design. They decided not to use a buck converter, which is usually what you see for the voltage regulation on motherboards, but here they decided to use a linear voltage regulator. And maybe it's just a poor design, and maybe everything is working fine. And, well, the board is working fine. It's been running 3D Mark for half an hour, so that's why the temperatures are a little bit higher than before. I'm giving it a proper workout, looping 3D Mark with the onboard graphics, and it's been rock solid. I haven't had a single crash. Everything is working, so maybe it's just a bad design, and me replacing the capacitors hasn't really changed anything. But yeah, I'd love to hear your take on this issue. Here we can see how the entire PCB area is warmed up because the component is using the PCB as a large heatsink here. I thought about maybe replacing the SMD regulator with a through-hole one and then mounting a heatsink, but again, is that going to improve the situation much? I'm not sure. The components are rated for the high temperature, so maybe everything is fine and I should just leave it and use the board as is. And while we're looking at some footage of 3D Mark looping on this motherboard, let's wrap up this video. So for me, quite a few takeaways. The desoldering process, well, as much as I like using the PCB preheater, applying fresh solder and flux, it seems the heat gun in combination with a desoldering tool seems to be working really well. I still need to dial in the temperatures. What I have now seems a little bit on the hot side, but maybe that's just what it takes. And circling around the pin with the heat gun definitely seems to be working better than just pointing it directly on the leg and blasting the heck out of it. I got a basic understanding of motherboards and voltage regulation, that there are two approaches. One is using the buck converter, switching on and off very fast and then smoothing it out with capacitors. The other one is using voltage regulators. Sometimes a combination of two, where the buck converter steps it down to something a little bit higher than the voltage regulator. And from my understanding is that using a linear voltage regulator, you will have a smoother voltage, less ripple. I believe that is the main distinction. But using the buck converter, it is much more efficient. You can step down from a high voltage to a really low voltage in an efficient manner. You're not losing too much heat. So for whatever reason, on this motherboard, they decided to use a voltage regulator. I'm not quite sure why. I'm sure there's a reason behind it. Maybe it's to do with cost, maybe with stability. I'm not sure, but it is what it is. So there you go, guys. This was my attempt to repair this OEM Socket 939 AMD motherboard with Nvidia chipset. Well, that's it for today's video. I hope you enjoyed it. If you want to stick around and see similar videos to this, why not subscribe? Give it a thumbs up and please leave a comment down below. I always love reading and hearing from you. And that's it. Thank you so much for watching, and I shall see you soon with another one.